Assalamualaikum and hi everyone, so welcome back to my new video. Okay, so in this video I'm going to explain to you about calorimeter. So this should be my first part of calorimeter. Okay, so there are two types of calorimeter, which is we have simple calorimeter and bomb calorimeter. Okay, so what is calorimeter? So calorimeter is a special types of device which we use to measure the amount of heat released or heat absorbed through a chemical or physical reaction. Okay, so these two different types of calorimeter has been used widely in the experiment. Okay, so the simple calorimeter will be introduced to you in the experiment 2 for your thermochemistry. So this simple calorimeter, okay, use the concept of styrofoam cup. Okay, and then the styrofoam cup will be covered by a lid, and there are two different holes. Okay, as you can see in this picture, there are two different holes. Okay, the first hole will be used to insert a stirrer. Okay, so you're going to pull up and down to stir the solution inside it. Okay, and the second hole is to fill up the thermometer. Simple calorimeter. Okay, sometimes we're going to ignore the heat capacity of the calorimeter, but sometimes it might be included, so you need to include the calorimeter into the heat calculation. Okay, whereas in the bomb calorimeter is a special kind of device which being used widely in the industrial, okay, to study the amount of heat change throughout a chemical reaction process. Okay, so in the bomb calorimeter it has a specific value of heat capacity. So heat capacity can be written as Ccal. Okay, so in the bomb calorimeter you cannot ignore the heat capacity of the calorimeter, and it should be included in the heat calculation. Okay, so what is heat? Okay, so heat is a kind of energy where it can be transferred between a systems, okay, from a higher temperature to a lower temperature. Okay, in this case, okay, in our thermochemistry topic, we're going to assume there is no heat loss to the surrounding. Okay, so the amount of heat transferred from one place is being conserved and will be accepted by another systems in the exact amount of how much is being transferred. That means how much heat is being released from one system will be equivalent to the amount of heat absorbed by the another system. So this is it, concept of heat. You always need to remember amount of heat released must always equals to amount of heat absorbed. Okay, this equation will be written in most notes and lecture notes. Okay, and you also need to use it when you're trying to solve any thermochemistry problems, especially whenever it's related to your calorimeter. Okay, so heat release we always write it down as Q release equals to Q absorb. Okay, right, so amount of heat can be calculated depending on either you were given heat capacity, okay, or specific heat capacity. Okay, so what is the difference between these two? Okay, so heat capacity is only to measure the amount of heat needed to raise a temperature of a substance by 1 degree Celsius or 1 Kelvin. So whereas specific heat capacity is the amount of heat needed to raise a temperature of 1 gram of substance by 1 degree Celsius. Okay, so you can refer to your lecture note for a written definition between this heat capacity and specific heat capacity. If it's a heat capacity, we always write it down as capital C, whereas if it is a specific heat capacity, we always write it down in the small c. Okay, so the unit of heat capacity is joule per Celsius, whereas the unit for your specific heat capacity is joule per gram and per Celsius. Or if you use temperature in Kelvin, that means it's per Kelvin. Okay, so if you were given the heat capacity, okay, so you can calculate heat equals to C times with the change in temperature. Okay, but if you were given a specific heat capacity, the amount of heat can be calculated by amount of heat equals to mass of the substance multiplied by the specific heat capacity multiplied by the temperature change. Okay, so you need to memorize this simple formula in order for you to solve any calorimeter problems. Okay, I give you 5 different questions for your first hour tutorials. Okay, so all those questions will use the concept of simple cup calorimeter. Okay, so let's look one by one. So this is the first question where you were given 550 grams of water. Okay, is heated from 7.15 to 88.50 degrees Celsius. So calculate the amount of heat absorbed by the water in the kilojoules if the specific heat capacity, if the specific heat of water is 4.18 joule per gram and per Celsius. Okay, just to let you know, okay, the value of specific heat and heat capacity is already fixed. So the questions will give you the value of specific heat capacity or heat capacity in the questions, or unless they want you to calculate that two different unit. Okay, so let's try to solve this question. Okay, so amount of heat, so you were given specific heat capacity of water. That means we're going to use kilo equals to mass of water multiplied by specific heat capacity of water multiplied with the change in temperature. Okay, so mass of water in gram, because must be in gram because the specific heat of water is given in the unit of joule per gram per Celsius. Okay, so 550 gram multiplied by 4.18 joule per gram per Celsius, and the change in temperature, okay, higher temperature multiplied with the lower temperature. Okay, never forget about your unit so that you won't get the wrong unit at the end. Okay, so you will get a long answer, which is 187023.7 joules. Okay, usually we will never leave out our answer this way. We're going to simplify it into a scientific notation, or you can convert it into kilojoules. This is very large amount of heat, so I prefer to leave it in the form of scientific notation. So I'm going to simplify it. It will become 1.901235, okay, times 10 to the power of 5 joules. Okay, please make sure you write down your answer with the correct unit at the final answer. Okay, so let's move on to the question number 2. Okay, so this is the question number 2. Okay, so 77.5 gram sample of an unknown solid is heated to 60.50 degrees Celsius and placed into a calorimeter containing 90 gram of water at 23 degrees Celsius. Okay, so that means, okay, 62.50 degrees Celsius is the initial temperature of my solid, whereas 23 degrees Celsius is the initial temperature of water. Okay, if the final temperature of the solid sample and water is 27.50, okay, so the temperature change, okay, so the final temperature will be equal for both solid, which undergo heat release, and the water, which undergo heat absorb. Okay, so the final temperature should be equivalent in both sides. Okay, so the question asks you to calculate the specific heat of the solid. Okay, means specific heat capacity of the solid. Okay, so let's list down the information that you have. Okay, so we have here for solid, okay, mass equals to 77.5 gram. Okay, initial temperature equals to 62.50 degrees Celsius. Okay, so final temperature equals to 27.50 degree C. Okay, whereas for my water molecule, okay, mass of water used in this one is 93 gram. Initial temperature of my water is 23, okay, and my final temperature of the water is 27.50 degree Celsius. Okay, how we want to know which one undergo heat release and which one undergo heat absorb? Okay, so you have to look at the temperature change. Okay, if there is an increase in temperature, okay, an increase in T means heat is being absorbed. Okay, but if you see a drop in temperature, okay, that means the heat is being released. Okay, so look at the solid. Okay, initial temperature of the solid is higher than its final temperature. Therefore, your solid undergo heat release. Okay, whereas in your water, initial temperature is lower than your final temperature. That means your water undergo heat absorb. Okay, so now we already have enough information for us to calculate and solve this question. Okay, so let's write down. Okay, Q release, Q referring to heat equals to Q absorb. Okay, so release is referring to the solid, so you're going to have all of this into the question. Okay, so our solid also have specific heat capacity. Okay, so you have to write down. Okay, so this one C solid. Okay, this one CW. Okay, so Q release is for your solid and Q absorb is for water. Okay, so the formula, since both solid and water has specific heat capacity value, so your Q should be mass times with specific heat capacity times with the temperature change. So for the Q absorb is water, so mass dot water times with the specific heat capacity of water times with the temperature change of your water. Okay, whenever you are answering this kind of questions, okay, so this first one should stand for 1 mark. Okay, and the second one, you're writing down the formula. Sometimes they might give you 1 mark, or sometimes for the substitution. Okay, so let's substitute whatever that we have, okay, in the questions into the formula. So mass equals to 77.5 gram times with specific capacity of the solid is going to be find out. Okay, so temperature change, okay, so 62.50 minus 27.50, 35 degrees Celsius. So this is the temperature change. Okay, so 35 degrees C. Whereas for your water, we have 93 gram. Okay, specific capacity of my water is 4.18. So this is a fixed value. Okay, so the temperature change is from 23 to 27.50. So it becomes 4.50 degrees Celsius. Okay, so now you rearrange and find out what is your specific heat capacity of your solid. The specific heat capacity of the solid was found to be 0.645 and the unit is specific capacity is joule per gram and per Celsius. Okay, so let's move on. Okay, so in the question number 3, 300 gram sample of copper, so you have copper, is heated to 285 degrees Celsius. So this is the initial temperature of your copper, and then was placed into 1000 gram of water. So this is the mass of your water at 26.50 degrees Celsius. This is the initial temperature of your water. So the question asks you to calculate the final temperature of the water. Okay, so what is the final temperature of the water? Okay, given that specific heat capacity of copper is this and specific heat capacity of water is this. Okay, so this is your question 3. Okay, so 300 gram of copper, okay, is heated to 285 degrees Celsius. That means this is the initial temperature of your copper, and then was placed into 1000 gram of water at 26.50 degrees Celsius. So calculate the final temperature of water. So they want you to calculate what is the final temperature of the water. So they give you both the specific heat capacity of your copper and water. Okay, so to solve these questions, that means you need to calculate the final temperature of water, which the final temperature of water is equal to the final temperature of your copper. Okay, so first, let's abstract all the informations that we have. Okay, so copper, so MCU equals 300 gram. The initial of your copper is 285.0 degrees Celsius. And specific capacity of your copper is 0.385 joule per gram, okay, per Celsius. Whereas for your water, okay, so mass W stands for water is 1000 gram, okay, and then temperature initial of your water is 26.50 degrees C, and the specific heat capacity of your water is 4.18 joule per gram per Celsius. Okay, so let's solve this question. Okay, as usual, water will absorb heat. So Q release is for your copper equals to Q absorb, which is for your water. Okay, so MCU times CCU times delta T equals to CU. Okay, so MW times CW times CW, okay, times with delta TW. Okay, so let's substitute the information that we have into the formula. So 300 gram multiplied by 0.385 multiplied by, okay, so heat release, that means the temperature change referring to higher temperature minus lower temperature. So the lower temperature is the final temperature. So 285 minus T. Okay, whereas 1000 gram times 4.18, and for your water molecule, it absorbs heat. That means its final temperature is higher compared to its initial temperature. Therefore, the final temperature should be minus with the initial temperature. Let's expand. Okay, so it becomes 115.5 4180 T minus 26.5. Okay, so that means you have to expand, multiply this one with both and this one too. Okay, so we're going to move one of the T, okay, this T to my right side and this number into my left side. So this become okay, so that means now you can solve for your T. So your T, which is your final temperature, is equals to 33.45 degrees C. So this is the final temperature of your water as well as for your copper. Okay, so sometimes in your calorimeter, they might ask you to calculate the amount of heat released, amount of heat absorbed, or you might be going to a more complicated questions. Okay, like previously, in the second question, you were asked to calculate specific heat capacity of the substance. And in this example, question 3, you were asked to calculate what is the final temperature. So just to let you know and to remind you, the final temperature must be equal for both of the substance that undergo heat release and heat absorb. Okay, let's move on to your question number 4. 50.6 gram of iron metal is heated and put into 104 gram of water at 19.7 degrees Celsius. So that means this is the initial temperature of your water. Okay, if the final temperature of the iron sample and water is 24.30 degrees Celsius, what was the initial temperature? So they want you to calculate initial temperature of the iron sample. Okay, so in your question 3, you were asked to calculate final temperature, which final temperature should be equal on both sides. But if initial temperature, that means you have to solve it. Okay, it's not equal on both sides. Okay, so iron undergo heat release, that means its initial temperature is higher than its final temperature. Okay, so let's first abstract all the informations that we have. Okay, so mass of your iron is 50.6 gram. Okay, and specific heat capacity of your iron is 0.473 joule per gram per Celsius. Okay, and then you were given the final temperature. So temperature final of your Fe is 24.30 degrees Celsius. Okay, so well, for your water, mass of your water is 104 gram. Okay, specific heat capacity of water is 4.18 joule per gram per Celsius. And then temperature final of your water is 24.30 degrees Celsius, whereas the temperature initial of your water is 19.7 degrees Celsius. Okay, so from here you can calculate delta T, which is equals to 4.6 degrees Celsius. Okay, since we are going to calculate the initial temperature, okay, I'm going to use delta T first, and then I'm going to, from when I get the value of delta T, and then I'm going to add on with the final temperature of the iron, so that I will get the initial temperature, because that one is simpler compared to you include temperature initial minus temperature final into the equation. Okay, that one's require you a longer process. Okay, so as usual, Q release equals to Q absorb. Okay, so MFE times CFE times with delta T equals to MW times with CW times with delta T W. Okay, so let's substitute the informations into the formula. So 50.6 gram multiplied by 0.473 joule per gram per Celsius times with delta T. Like I told you before, I'm going to fix with delta T, so that later on I'm going to add the change in temperature with the final temperature to get the initial temperature of my iron. Okay, so mass of water is 104 gram times with 4.18 joule per gram per Celsius times with delta T. Okay, so we already calculate before. So temperature change of my water is 4.6 degrees Celsius. Okay, so let's solve on both sides. So on my right side, I will have it to be 1999.712 joule, whereas on my left side, when it becomes 23.934 Okay, so the unit is joule per Celsius. Okay, so to delta T. Okay, so to solve for my delta T, I'm going to move this one to my right side and it becomes a division. So 1991712 joule divided by 23.934 joule per Celsius. So my final answer will be in Celsius. Okay, so the temperature change is 83.55 degrees C. So my temperature initial of iron equals to 83.55 degrees C plus with the final temperature 24.30 degrees C, which is equals to 107.85 degree Celsius. So that's it for your question 4. Okay, let's move on to the final questions in your first hour tutorial. This time you were dealing with lead pellet having a mass of 26.47 gram, okay, with initial temperature of 89.98 degrees Celsius. Okay, was placed in a constant pressure calorimeter of negligible heat capacity. Okay, so even though it's being placed in the calorimeter does not include in the calculations of heat. Okay, so we're going to ignore the heat capacity of your calorimeter, containing 100 milliliters of water. So the water temperature rose from 22.50 to 23.70 degrees Celsius. So 23.17 degrees Celsius, this is the final temperature of the water and also the lead pellet. Okay, so you have to calculate the specific heat capacity of the lead pellet. Okay, alright, so this time you were given volume of water which you need to convert it into mass. So how are we going to convert it into mass? Okay, if you still remember, so this is the basic knowledge that everyone needs to know. Okay, density of water is 1 gram per cm cube. Okay, where cm cube is equals to milliliter. So if I have 100 milliliter, that means it's actually equals to 100 gram. Okay, how do I convert it to gram? Just simply 100 milliliters, which is 100 cm cube, you multiply by the density of water, 1 gram per cm cube, so we'll get the value of mass of your water in gram. Okay, so let's abstract the informations that we have. Okay, so MPB equals to 26.47 gram. Okay, and then temperature initials of my lead is 89.98 degrees Celsius. Okay, whereas for my water, okay, temperature final of my lead is 23.17 degrees Celsius. So again, temperature final of both lead pellet and water should be the same. Okay, so because once they reach the same temperature, the heat transfer process is stopped. Okay, for my water, okay, so I have 100 gram, and then initial temperature of my water is 22.50 degrees Celsius, and temperature final of my water is 23.17 degrees Celsius. Okay, so from here, let's first calculate the temperature change. For my lead pellet, it becomes higher temperature minus the lower temperature, so you will get the change in temperature, which is 66.81 degrees C. Okay, for my water, okay, so again, higher temperature minus initial temperature, okay, so we get 0.67 degrees Celsius. Okay, so again, to remind you for this final question, how to determine which one undergoes heat release and which one undergoes heat absorb, you have to refer to the temperature. Okay, so like this one, okay, your lead pellet has higher temperature of the initial temperature. So initial temperature is higher than temperature final. That means Q release. Okay, Whereas in my water, okay, initial temperature is lower than my final temperature. That means heat being absorbed. Okay, that's how we determine which one undergoes heat release and which one undergoes heat absorb. Okay, let's focus on solving the question. So, heat release equals to heat being absorbed. Okay, so heat release is for my lead pellet. So, MW, okay, MPB times with CPB times with delta T PB equals to MW times CW times delta TW. Okay, so mass of my lead pellet is 26.47 gram. Time of CPB is to be found. Okay, so delta T, the temperature change for my lead pellet is 66.81 degrees Celsius equals to 100 gram time with 4.18 time with temperature change of my water is 0.67 degree Celsius. Okay, so let's solve to calculate what is your specific heat capacity of your lead pellet. Okay, so if you solve it, you will get the heat capacity to be 0.158 joule per gram per Celsius. Okay, so throughout this video, you have made to several different questions in your simple calorimeter, where all of the questions that I have discussed here, we ignore the calorimeter heat capacity of your calorimeter. Okay, so we don't include calorimeter into our heat calculation. Okay, so we'll just between one substance going to undergo heat release and another substance will undergo heat absorb. So this is a simple calorimeter. So my second part video of calorimeter will be discussing on a more difficult part, which we will include calorimeter into our calculation. Okay, so in these 5 different examples, okay, so you have made with first, you need to calculate what is the amount of heat being transferred, okay, amount of heat being absorbed or amount of heat being released. Okay, secondly, you already made with how to calculate the temperature change and temperature final, initial temperature, and in the same time, the last one here, you have to calculate what is the specific heat capacity of the other substance. Okay, so I hope all of these 5 examples, okay, helps you to empower your understandings on the basic simple calorimeter. Okay, thank you for watching. Don't forget to keep trying answering questions that I give to you for your second hour tutorials, and see you guys again in my next video. Bye bye.